And so there we just saw a test execute, and we can kind of see here on the commands what happened. So here we are starting a session, and you can see some information about what happened. You can see some desired capabilities, and then you can see the response of that command. So then next you can see that at 47 seconds. So you can see that about 45 seconds was what it took for our device to start up. And then at the 47th second, we are now able to load the URL. I think there's a bug actually in Sauce Labs that these screenshots are a little bit behind because, yeah, you can see here, it loaded the URL here, but it's showing this thing. But so next, you can see we're finding the element. So here you can see that here is what we used. We used the ID and username. And then here's the status code. 200 is good status code. And then we send the keys to that element, which was, it shows standard user. And for debugging purposes, I'm going to explain some important stuff here. In this find element command, you can see that this element, we used this information, and what we got back was this response showing us this basically element identifier, kind of an index, a number, an index, or yeah, an index is a good way to refer to it. And so this one, we're referring to it as 5,000, right? And so any future interaction you're going to see in Sauce Labs will be, you can see this element slash 5,000. That's the element, the exact element that we found in here. And so you can see here that we're going to be sending keys to that exact element. Here we're finding element, the next element, you can see this one is 5001, just incremented. And so that's how actually it's going to go. Every interaction in Sauce Labs, when we do a find element, you're going to get an incremented identifier, incremented index for that element. And then all interactions will be, you'll be able to tell that here we're basically interacting with the password field. And so here you'll see 5002, and that's the login button. You can see ID login button, and we're clicking that login button and then killing the session. So let's see here. So that kind of explains this. So hopefully that makes the debugging easier for everyone. Now, there are screenshots available here on the side as well. These will actually map to what's going on. So see, this one correctly maps to what actually happened in the video. The video is just a little bit behind, I think. Again, as I said, bug on our end. But you can see these screenshots here. Some other potentially useful stuff is this metadata. What's useful here potentially is to see the configuration used to start up this test. So you can see like something like Appium version. That usually a lot of times can cause potential issues in our automation, especially iOS. Maybe there's a bug in a Appium version, and I've seen bugs in sometimes few new Appium versions that didn't exist in old Appium versions. So you might notice that, oh, I'm using a new Appium version, and now I'm having this weird behavior in my test. Maybe you need to roll back to your older Appium version by coming here and saying 1.16.0, for example, and then that might fix the issue. I've seen that happen sometimes. Appium, I think the difference between web and mobile automation is web automation is pretty mature. Mobile automation is not mature at all. And so they're still trying to iron out a lot of issues, especially in related to iOS, because just Apple in general makes access to their platform extremely hard. You know, they're obviously super secure, but in terms of third-party interfaces, talking to them, they don't make it so easy. Android makes it drastically easier. The other thing I wanted to quickly mention here that I forgot to mention is, especially for emulators, simulators, and real devices, right? Because they're on mobile, what's really important and going to come into play is the actual display of your application, because most of our applications these days are responsive. So when you're doing automation, it's really important to consider how it's going to look. So what you can do is actually come here and toggle this device toolbar, and you can start looking at your application on the actual device, right? So you can see this is actually, again, default from Chrome Developer Tools. And you can see here it provides you many different sizes. So here I'm picking iPhone X, and this is how our application will look on an iPhone X device. we can scale it out to 100%. And so with this little simple app, it's not that big of a problem. But with larger applications that don't fully fit on the screen, let's say we're trying to interact with the element way below this, we will actually need to swipe up in order to get to that element a lot of times. And so that's one of the problems we see with automation is with iOS automation and mobile automation in general is when people try to interact with an element that's below the fold, they're not able to find it, and that's because they need to scroll down. And so make sure you look at your application on the correct device, right? Pick whatever device you're trying to automate, and then you'll be able to see, oh, okay, maybe I need to scroll down here first before I start trying to interact with an element. Let's see here. Let's look at a different website. Let's just look at saucelabs.com. So this is what it looks like on iPad. Then let's say we're trying to interact with this, maybe this continuous testing button. On an iPad, it took several scrolls to get there, while on a smaller device, like maybe an iPhone 6, which is very thin, it'll take way more scrolling to get to that point, right? So there is no API that will automatically figure that out for us. Basically, there's API for us to scroll, but then it falls on us as the developers to come up with that logic to scroll to the right place. Yeah, so one strategy that we can do is to figure out the entire size of the device, of the screen, and then scroll until we're at the end of the screen, looking for elements. That's basically the best solution that I've seen. It's just you check for an element whether it exists. If it doesn't, you swipe up, and you just keep doing that until the end of the screen. Okay, cool. So let's continue talking here about debuggability. So another thing that I don't see utilized too often, which I think is very helpful actually, is Sauce Labs has these annotations that you can add to your code using the JavaScript executor. And so we can actually just take this right here, and I'll show you exactly what they do. And these can actually be very handy. So these are basically like adding comments to your test automation code. So here you can come and let's import our JavaScript executor. And so all you have to do is supply the string of the comment that you want. So you have to leave that part in there, but let's add a string. And so here we can say open login page. And then let's copy this. And here you can do starting login. And then here you can do ending login. And I'll show you what comes out of it. And I actually like to put a thing like that in there, just to differentiate it in the UI. So let's take a look what happens here. And the way I recommend using this is you guys will have page objects that wrap this kind of functionality, right? This might be a login page.open method. And so inside of there, my open method will actually just have this exact code in there. And so then we'll be able to see our automation entering our login, right? Let's say we entered right here, and now we start doing stuff and something went wrong, and then we never see this message. We will know that we got stuck in the login function and something went wrong in there. And so it makes it much easier to identify where something went wrong, while sometimes our tests might have, these of course are very simple, but you can imagine if we have hundreds of commands trying to figure out where what went wrong, it might not be so easy, and that helps a lot. Oh, I'm so sorry, I'm not updating the right one. Yeah, I copied the wrong one. So to comment, it's source context, not job name. But source context is for commenting. And yeah, you can update the job name of a test through JavaScript executor, or you can update it through mutable capabilities. That's a totally common way, right? Yeah, you just put name here and then the name of the test. But yeah, for some people, if they want to do it, I actually haven't seen anyone doing it through execute script, but that option is there. So let's try this again and run this. Yeah, so by the way, since we're talking about, you can see there's multiple JavaScript executor commands you can use. Again, for me, the most useful one is the source context for commenting. Yeah, that's pretty much it. Let's take a look here to see our tests. It's still running. While that runs, I can show you how we would have done this with a page object. So let's just quickly create a new login page, pass in our driver, and then do login. Just pretend, right? Let's create this class login page. Yeah, great. Just assigning a local driver. Oh, field. Okay, cool. And then they'll want the login method. Okay. And let's just throw this logic in there. And I'll show you exactly how we can use this. And so actually, you can even make it really dynamic by doing this. You can do, here, I'll put it up here. You can dynamically get the name by throwable, get stack trace of the first element, and then get method name. And so then this will dynamically get the method name, and then we can do starting, up, enter. That method name, and then here we're exiting that method name. And I'll show you in a second how that looks. And so here, yeah, here's our test that we just executed. You can see what shows up here. Here we know we're opening the login page, and that's pretty self-explanatory. But in larger methods like this one, we can see where we're starting the login and ending the login and what happens in between. And so, of course, if something failed here, we would know that, oh, okay, we're stuck in the login method. Let's take a look what's going on in there. And if we're doing it with a page object, let's take a look how that looks with the dynamic method generation. So while that goes, I can even talk about further expanding this, especially for debugability. What you can actually do is instead of just doing this, you guys can actually have a reporter class, and the reporter class can do something like reporter.log, and in there you can insert JavaScript, these sauce labs commands, plus you can log to like your text log, for example, using like log4j or something. And then also you can log to APIs and so on and so forth. And then you can just basically have a single object that logs throughout your test, but what it does for the logging, you can basically configure in a single method. That would be the next evolution of this. Okay, cool. And so here is our test again that just executed. You can see this is the same, but now here you can see that we're dynamically getting enter login and exit login. And so now we don't have to be basically typing in the strings. We can just, if we just copy this code, these 2 lines of code here, it'll be sufficient. And then of course, if we wrap this inside of a logging method, all we'll really have to just do is pass in this. I like to do like reporter dot log entry, And then you can log entry and pass in the method name. And here, a reporter.log exit, and then pass in the method name. I think that's pretty much it. I don't know if I left anything not covered. Let's take a look here. So there's this other demo app. I know it has an iframe in it. Iframes. Oh, there. So here's iframes. So if we inspect this, so yep, you can see how the iframe shows up. And so, yeah, if you want to interact with the content inside of the iframe, you have to switch to the iframe. Then you can see iframe has its own HTML in here, and only then you can interact with it. You know, you would do driver dot switch to frame, and then you can put in here the name, for example, which in this case, the name of this frame, let me see. There it is. So this one has an ID. So we can pass in like the ID of the iframe, or you can even pass in a name. This one doesn't have a name, but you can pass that in and then you can switch. Let me see. I think it takes only the name. Here, let's go back. We haven't interacted with a frame in a while. String. Let me just create a new test. Let's copy over this whole thing. I forget if it's a name or ID with a frame. Let's just double check. Frame, and we can navigate to this URL here, and then we can do driver that switch to frame, and let's see if we can pass an ID. Why can't it let me click it? MC. I don't know if it's my keyboard. MCE 0 iframe. And then if we're inside of this, we can then try to find this element. Let's say this one, tiny MCE, which is inside of it. So we switch to it, and then let's try to find, oh, and we can try to find it by ID, and then we can do tiny MC. So if that works, we'll be able to find it. Otherwise, we'll get a no such element exception. Give this a run and see what happens. Yeah, it takes a string or a web. Oh, so it takes a web element too. So we can even do, you know, in here frame, and then you can do driver.find element by ID, and then that'll definitely work. Here's our test. Oh, it passed. So nice. So that worked. So it does take ID as the default string, looks like. You can find it. But of course, let's keep me honest, make sure that I'm not making stuff up here and just change that to something fake. and just rerun it. But yeah, so here you can see that it was able to find the element tinymce. Yep, and it returned. Otherwise, it would fail, and you can see how that would look. Actually, not only will it not have a valid ID, it won't have a 200 response, and you'll see a red fail here, which I'm actually really happy we're running this new test. You'll actually get to see that. Yeah, because I only showed positive stuff so far. Yeah, so perfect. This one failed. So in a second, we'll see the failed commands. And oh, interesting. Why didn't it work? Huh. That's interesting. Is it only for frames? Oh, because it couldn't find the right frame. I wonder if that's only happens for, yeah, like I said, I haven't interacted with frames in a long time. So let me check here. I wonder if that only happens for frames. So if we try to find this element, that'll definitely fail because it is inside of an iframe and we're not switching to a frame. Oh, you know what it could also be is that maybe the Selenium API, when you switch to a frame, even if it doesn't exist, it still tries it. Then regardless, you get a 200 response. See, test still going. Code failed, and now we should see failed command in here. There you go. See, yeah, defined element because it was looking for that tiny MCE, which of course is inside of an iframe, and because we didn't switch to an iframe, it could never find it. And so that's what it would show up as, and you'll see. And this is okay to see, but you kind of know that whatever element you try to look for isn't there. And if you're doing explicit waits instead of just find element, you'll see multiple of these as we're trying to poll the application for this. And then of course it may or may not find it depending on what's going on in your application.